All right, now we're going to do the second free response from review day 12. We are given this equation here, and we're supposed to show initially that dy dx is equal to this. So what they want to see is an implicit differentiation to start with. So 4x plus 6y times dy dx. And then we have a product rule. You got to be real careful. I would consider that minus 4x together as one function. So the derivative is negative 4 times y as is. And then repeat negative 4x times dy dx equals 0. That's probably the biggest place somebody will make a mistake is right there. They'll put a plus instead of that minus. So again, if you see a negative like this and you're about to do product rule, just tag it on to that number. Let that be part of that whole function. All right, now we have to get the dy dx terms to one side. So we're going to have 6y dy dx minus 4x dy dx equal, and then we'll subtract, we'll add this 4y over, and we'll subtract this 4x over. Okay. Then what we'll do is we'll take dy dx out, which will give us 6y minus 4x equals this, and then we divide dy dx equals 4y minus 4x over 6y minus 3x. Now, that's not what they want to see. All they really want you to do then is to divide everything by 2. So you can either pull that 2 out like that and then have it cancel, and then you'd have the final answer. So I'm running a little bit out of room here, but hopefully you see it. So this is 4. Cancel that, and now we have what they asked for. Dy dx equals 2y minus 2x over 3y minus 2x. All right. So they gave you a point for the initial implicit and then a point for all of this here. And you just have to have enough steps for them to see. You can't jump over steps and assume they know what you're talking about. Make sure you actually go through it. All right, B. Find the slope of the line tangent to the curve each time x equals 6. So there's a little bit of work involved in this one. We'll start it down here. Basically, first you have to put 6 into your function and figure out what y equals. So if we put 6 into there, I'm going to get 2 times 6 squared, so 72 plus 3y squared minus 4 times 6, so 24y equals 36. So now if I bring this over, I'm going to get 3y squared minus 24y plus 36 equals 0. So y squared minus 8y plus 12 equals 0. Y minus 6, y minus 2. I get y equal to 6 or 2. Okay, so there's my worked out solution for y. So I know that x equals 6, and these are the two places that happens. So basically what they want to see now is you to figure out what the slope is. What's dy dx at 6 comma? We'll start with 2. And to get that, we're just plugging it in. So we're going to get 12 minus 4, so we'll get 8, and then I'm sorry, I flipped that around now, didn't I? 4 minus 12 would be negative 8. And then 6 minus 12 is a negative 6. So I end up with 4/3 as the slope for that. So that would get you a point. Okay. And then we'll do the other one for same thing, dy dx at the point 6, 6. And if I do that, I'm going to get 12 minus 12, which is 0, over 18 minus 12, which is 6. So we'll get 0 for that one, and that was worth a point. So all this other work here that you had to do, although it's a lot, didn't get you really anything. It wasn't until you plugged those points back in and found the slopes that you got the full credit for that. Okay. C says find the positive value of x in which the curve has a vertical tangent. So we'll have a vertical tangent when our slope is undefined. And our slope will be undefined if 3y minus 2x equals 0. So we're going to set 3y minus 2x equal to 0. If you did that, you got a point for this problem. Now the rest of it is just craziness. You want to take 3y equal to 2x and then have y equal to 2/3 x. And you're going to basically do a substitution now. Put that in for y here and here. It's going to give you, we'll do it down here, 2x squared plus 3 times 2/3 x squared minus 4 times x times 2/3 x equal to 36. So we're putting 2/3 x in for the y in both of those spots. All right, gives us 2x squared plus, this is going to be 4/9 times 3. That's a 4/3 x squared. And then this is going to become an 8/3 x squared equal to 36. So now if I kind of work this out, I have basically 6/3 plus 4/3 would be 10/3 minus 8/3 would be 2/3 x squared equal to 36. If I multiply by 3/2 now, if I multiply by 3/2 on both sides, I'm going to get x squared equal to 54. And if I take the square root of that, and then x equals square root of 54. Now we are asked for the positive value, so we're not going to consider the negative of this. So just the positive, that would get you another point. Okay, if you could do all of that, 1 point. If you can't do all of that, it's just 1 point, right? You don't get too panicked about it or anything. It's again, do what you can, right? That's what we have to do in a few weeks here. So D says let x and y be the functions of time related to this equation. At time t equal 1, the value of x is 2 and y is -2. And dy dt is 4. What's dx dt? So now they want us to integrate with respect to time. So if we kind of redo it, we're going to have 4x times dx dt plus 6y times dy dt. Okay. Then again, we got to do that same product rule here, being careful with that negative. All right, and so there's our initial derivative. And if you had that, that was worth a point. Okay, and I think they would even go ahead and give you a second point maybe at this point, but maybe you'd have to start plugging some things in to get the second point. So let's go ahead and do that. From the directions, we were told x is 2, y is -2, and dy dt is 4. So we're going to go ahead and put that. So this is 4 times 2, that's 8 dx dt, which is what we're trying to find, plus 6 times -2, -12, times 4, which is -48. And then -4 times dx dt, which is what we're trying to find, times -2 would be a +8 dx dt, minus 4 times 2, which is 8 times dy dt 4, so that's 32. All right, equals 0. So what we can do is put those together now. We've got 16 dx dt's equal to 48, 32 over here, which would be 80. And so if we divide, we end up with dx dt equal to 5. And that, so 1 point, again for this, 1 point for plugging them in and showing that you understand where those values are, and then 1 point for our final answer there. Okay? So this one was a lot of algebra. You can see a lot of work all over the place on this one, right? Definitely not an easy problem, but that's how we do it.